Hello. Here we are, back looking at this Commodore PET. So I've been waiting again for the screen to fail. And so far, it's not failing. Which is all fine. I really don't want it to fail. I just would like to know why it is failing. So I have rinsed off the magic eraser, and I gave everything else one more rub, including some of the parts on the right side I really couldn't get to. And boom, we now have a really sharp, no pun intended on the sharp thing, but a really lovely PET 2001 series with a small 9-inch screen and a working keyboard and a monitor that comes and goes. So I will figure out what's what. The circuit board inside is indeed mighty dusty. This one, as I said before, it only has 16K of memory. It has places available for more to be put in, but I don't think I will. It could be upgraded to Basic 4, but I don't think I will. I don't remember if this is the original. I think there were 3 different versions. I think one had the number sign, or the pound sign. Another had plus signs, I think, maybe. And then maybe the last one had 3 asterisks and said Commodore Basic 4.0. But that could be wrong. But I'd say it's a pretty good guess. I would say. So, we are clean, and we are still a little bit intermittent, but we're not bad. So, I'm going to do another little program. I'm going to count to 1,000, but we're going to do it differently. So, we will say, much as we did before, for I equals 1, 2, not 2, 2, 1,000. You know what? As always, you always forget to put lines in you mean to put in. I'm going to put in line 5. And for those that are not aware, you can put in cursor movements and other things into your print statements. So what I'm going to do is I'm going to press Shift and clear home, and that puts in a heart. And what that will do is anytime the program is run, the screen will clear. So then everything is gone. So it's nice and clean. Anyway, it just makes it so that there isn't stuff left over. So then I'm going to change this. See, I want this number to always end up in the same spot. So I'm going to do that. Now that is an unshifted clear home. It is. And then I'm going to go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Those are cursor down positions. So right now, whatever I print, every time it will print it to the top of the screen, then it will go down 10. And maybe I'll go over 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 13, 14, 15, 16, 17, 18. And I'll put a quote. And then a semicolon and an I. The I key is still a little funny. And 30, I'll say next. Yeah, that key is weird. Oh, there it's up again. Little soft. So when I list, I have a little program that if I've done this right, it will clear the screen and then it will start counting to 1,000. And then it will print what it's up to. And basically what this should look like is the numbers running over each other. And it will print much faster than if it had to redo all the screen every time. Let's try it. It should, somewhere around here, it should happen. Oh yeah. And now it is counting. And I don't, oh, well, hang on. In my mind, this counts faster than if it had to print them all across the screen, down the screen, da-da-da-da-da. But does it? Well, I could always get out my iPhone and time it. But once again, we don't need to do that. We have a thing, at least I think we do, in this machine, unless we don't. Let me try that. Rub. Oh dear. Okay, we do. At least I think we do. Now I'm going to print TI $. Okay, right. So TI string is the time. It's a clock you can set every time. So, in my mind, if I have, I'm sorry, I'm taking shortcuts here. Okay. So the first thing it does, it sets TI string to 0. It clears the screen, it starts counting, and then it prints the numbers. And when it's all done, at the end, it will print TI string. And it will tell us how long it took. Now, in my mind, this printing and counting is faster than if I had it run down the screen or well, like I did before, where it was running and moving the screen and doing all that. In my mind, it's faster. Is it faster? I don't know. I've never really taken the time to figure that out. But in my mind, it's faster to do it this way. So it's now up to 800, 900, and 1,000. Then at the end, it's going to tell me how long it took. 33 seconds. So, how would I do this? Well, I'm going to put in line 15, print I, semicolon. That's kind of what we did before. So, but then, because I really don't want to lose this line, otherwise, you know, I could do it again. I'll change this to a remark, which basically means it does not execute. So, same program. Now, does it take extra time because it has that line in there? And it has to kind of look at it? I don't think so. Anyway, let's see. It took 33 seconds for it to print the number in place, and now it's going to clear the screen and start counting. So, in my mind, it's faster the other way. But is it faster? I don't know. See, the other way, it had to do more things. It had to go up to the top of the screen and go down and go over and all that. And you know what? This is looking faster. Although to me, in my mind, seeing the numbers sit there running over the top of each other is faster. But according to this, it's not. So maybe it's because of all this. But still, I like when the numbers run like that, over top of each other. It looks really cool. And I always thought it was faster. It looks faster. Maybe because it looks like they're... Well, it looks... So it's 15 seconds faster. to do this. At least that's what it was the time before. So we're up to 8, 9, how long did this take? 18 seconds. Well, I'm tempted to try something here. I'm curious. If I change this and tell it to clear the screen, oh, sorry, it's not going to clear this. It's just going to move the. It's just going to put the cursor at the top and have it run. So it's going to do much the same. It's just not going to have as many places to go. There, it's running. So is this faster with less cursor movements? I don't know. 16 seconds. So that was faster than we'll take out the remark there. So now this should count once again in the middle of the screen. So it was 16 seconds if it sits in the top of the corner, top corner of the monitor. It was 18 seconds if I just have it print. And I'm suspecting once again this is going to be like 33 seconds. But you know, to me this looks better. I like it in the middle of the screen. But you see, these little things that, you know, now who would even think, because of course things run at giga everything, 33 seconds. So these cursor downs and these cursor overs, or sorry, cursor right, along with the same number, basically, compared to just going to the top of the screen and leaving it there, it takes the computer twice as long. So remember, these machines were not running at high speed. I think it was 1 mega. 1 kilohertz. Kilohertz? The clock speed. Oh, my mind goes blank. Anyway, 1 megahertz? Anyway, they were not running at blistering speed. But you see how just adding a little thing takes, or what looks like a little thing, adds tremendously to the time that things take. So I just made another line in there, which is an awful lot like line 25 is now the same as 20, except it's going to do the same thing 2 lines longer, or 2 lines farther down. There. Look at, there are the numbers counting away. So when it did it once, from 1 to 1,000, it was 33 seconds. But now we're asking it to print it. All we're doing is saying, hey, print it. Print it twice. But each time it's doing the printing, it's sending the cursor here, sending the cursor there, sending the cursor there. So I can tell already this is taking longer. It is. So will it be twice as long? Maybe. So it was 33 seconds. We're coming to the end. And we are going to find that it takes it a grand total of 106. Pretty much double. Wow. Alright. Let's try something else. Let's put a remark statement there. So what have I done? I remarked, as in made line 25 not execute, and I've changed line 20, so it's going to print the number twice next to each other. So one would think that this should take a little longer, but probably not as long as when it had to redo the whole print up to the corner, back down, over, and all that. But it does seem slower. It does. But is it going to be 1:06? I don't think so. I don't think so. Let's see. 49. Kind of in between. Interesting. There. Let's see. Oh yeah. Now this has gone a little weird. Yeah, hang on here. Because as the numbers print, they kind of run over each other. I'm going to... That's another thing about the later PETs. See, I have to push the key down every single time. 1, 2, 3, 4, 5, 6, 7, 8, 9. We'll move that over. But still, strange things happen to the numbers when things get bumped over. Because it's not up to 15 or 17 or whatever hundred, but numbers get left on the screen. Of course, I could always add a thing in there to clear the screen in between each time. Yeah. So definitely, it doesn't take much to slow down. And remember, BASIC on the PET is an interpreted language. In other words, it's not machine language. Machine code is blisteringly fast. BASIC, it ponders when it runs. Each line comes in and then it interprets it and says, well, what do you think that really means? And then the computer thinks about it and says, well, I guess it wants to print that number. And it goes ahead and does it. But it does there's more time necessary for it to think about it. Yo, what are we doing here? So, we are getting there. Definitely having it print 5 times has slowed things down a lot. We're now up to 900. So I suspect this is going to be closer to 1.5 minutes or more. And here it comes. 1 minute, 39 seconds. To basically do the same. And as you see, these numbers have gone squirrely. They have. Because things get printed and then they don't get erased. They just don't. Well, that line remarkable. By the way, rem statements are pretty much there. I mean, you can leave yourself little notes. If you're running, this machine has 32K. Sorry, 16K. So if you really don't have a lot of memory, you can't leave yourself tons and tons of notes about things. So let's try line 12. We're going to print I. That's it. Print I. So we're not going to worry about cursor things. We are going to clear the screen, but inside the loop, which is everything between line 10 and line 30, we're not going to do anything. We're just going to print I. And there it goes. So in my mind, this is slower than if it were to be printing all at the top corner of the screen. But is it? Is it slower? I think it is. But we'll find out. And we will see that it is, oh yes it is, 40 seconds. So, we're gonna, oh, no, we don't want to go there, hang on. So we now have 3 different ways of printing, sorry, 4 different ways, but 3 of them are disabled. Because anything that starts with rem, it doesn't go. So to me, it looks like the fastest way to count from 1 to 1,000 and print the numbers is to leave it in the top corner, 16 seconds. Excellent. So, remember TI string. And you know what, if you don't reset, like if I say, go to 5, it's going to go and count, but it's not going to tell me that TI string is 16. And why is it not going to tell me that? Because I didn't reset it. Because once you set it at 0, it will keep counting every second. It'll keep counting. But if there, 53. But it doesn't mean it took 37 seconds longer. It's because you don't reset it. It is funny at times, you know. Like if you do something with a variable, it just starts at 0, but it really is good practice to set variables at what you want them to be, even though it is 0. Like I should really put in line 2, I equals 0. Not that it makes any difference. But if you do that with all the variables you use at the beginning of the program, or it doesn't have to be 0, you can set it whatever you want it at, but then if somebody else is coming in looking, certainly they can tell right quick all the variables that you have used. And if you put remarks in, you can tell them what they do or what they're for. You can. And really, if I run this again, just by adding that one thing in there, it's not going to change the speed. Anyway, so here we have the PET. You know what comes to mind? There it is, 16 seconds. What comes to mind with this monitor thing as I tap it, oh, it flickered a bit, is there, yep, there it goes, and now it's back, and now it's gone, and now it's back, is there could be a cold solder joint, or maybe not even a solder joint. There could be something very tiny inside. Even one of the chips where it's broken, but it's not broken, but just it is. Because you remember, the connections in there are the size of like hairs. Anyway, before I do anything serious with this machine, be it sell it or whatever, I think I would like to figure out what it is. I would. And why it is doing that, especially with... There. I strum my fingers, it's gone. I strum my fingers, it's back. So it's some tiny, tiny little thing. Another thing, you know, a modification I would have done long ago, had I thought of it on the PET, is, you know, when we used to run a bulletin board. We had a variety of bulletin boards. Well, they were all one, but, you know, all under the same name. But especially now, in these days of being electricity conscious, pretty much the thing that uses the most power in these machines is the monitor. So it would make sense, if you're going to have something running all the time with a built-in monitor, that somewhere there's a switch for the power and somewhere there's a switch for the monitor. So when running a bulletin board, the monitor, which doesn't need to be on at all, can be turned off, and I bet you the computer would then be running maybe a tenth the power. So that's one modification, I think, if I was going to have something running for a while, like a bulletin board or anything else, that I would want to have on there. But then, of course, it's not stock anymore. It's modified. But, you know, so be it. In these power-conscious days, I think that would be wise. Because, really, the screen, when you're using the machine, yes, the screen has to be on. But, you know, I mean, going back on that, a magical thing was, I remember when we were running the Bradley Bullish bulletin board system, and it was out of my grandmother's basement in Toronto. It was cool. There would be no noise from it. What it was cool, we would always, of course, when it wasn't doing anything, the screen would be clear. Hello, Sheldon. But then when someone would sign on, it would show what was going on. But I remember sort of being asleep, and then kind of something would jar me, and I'd look over, and there would be the screen starting to fill with the text, and the person signing in and carrying on. So that was kind of cool. But mind you, that what I found kind of cool about that is the way the letters came in. Maybe we can do this. Excuse me. Let's see here. We do not want to just... Do we want a print eye? Yeah, we do. Hang on here. We'll remark that. And then we'll unremark that. Alright, so now, okay. So that's the way that goes. Okay, stop. So, now, and this of course gets messy, I'm going to put in 28 for J equals 1, 10. 1, 2, 10. Next, J. So now this is going to get into it. Now, this is not exactly how the the bulletin board stuff would come in, because it wasn't numbers. And it wasn't spaced out. It would just be whatever came. But it was kind of cool to wake up and look over and see that somebody, and you know, we had people calling in from all over the place. So we also had what was called the punter net. So sometimes it was a punter net node calling in to exchange messages. And that would be really fast. It would. So there. So we've added that. So basically what we did was we told it to slow down by telling it to count to 10. We can slow it down some more. So, once again, remember, you are the master of your variables. I suppose. In life, too. So, enough of the counting, enough of the variables. What we now have here is a very fresh, pretty PET with some sort of issues. You know, it could even be a cold solder joint on the monitor. There is a thing up there, this is the thing that scares me with high voltage, like the flyback transformer. But they do have a lot of juice running through them, and sometimes the solder just says, hello, that's enough. The only real monitor repairs I've done have been cold solder joints on the flyback transformer. Oh, look at that. I tap the table and it's back. So whatever is going on here is remarkably small. And here's another thing that happens. See, some things fail when they're cold. Other things fail when they're hot. And with these microscopic little things, if something has the tiniest little crack in it, it may not work when you first turn it on. But then as other things and that same chip start to heat up, contact may be reestablished. Anyway, whatever is failing here, it's very tiny. Very tapping the table, very discreet. And certainly it's not affecting the operation of the machine, except once in a while it goes dark. But I'm glad it's intermittent in the work, because if I got this thing and turned it on and nothing ever came up, I'm not sure where I would want to begin on figuring out, and especially with monitor things, because I don't like monitors. But with this one, of course, if I were to turn it around and look inside, the monitor would be lit up. So I guess at some point I would try and put this machine next to another machine and hook up the power and everything else and see if the monitor came on, and then try and go from there. Who knows? Maybe one time we'll get into that. Anyway, the PET is still counting. It is. You can always count on the PET. So, we have a pretty machine. We've done some counting. And I think Sheldon was here. Sheldon. Hello, Sheldon. Are you going to come up? You going to come up? Up on the table? Going to come up and say hello? Sheldon? You going to come up? Do you want to... Here. Sheldon. Do you want to come up on the table? Want to come up here? Do you want to come up here? No? Okay. No. Sheldon is... Oh. Hello, Sheldon. Why don't you just come up on the table for a moment? There, Sheldon. We haven't seen Sheldon for a while. You want to type on the keyboard? Oh, I know the monitor went off, and now it's back. Boy, it's a tiny little something in there. Sheldon, what's over here? Look here, Sheldon. What's up here? What's up here, Sheldon? Oh? What do we got here? Sheldon. Sheldon. Where are you going, Sheldon? Have you had enough up there? Oh, Penny is here. Penny hardly ever comes by. Yep, so here we are with our pets. You had enough, Sheldon? You want to get down? Do you want to get down? Sheldon, come on over here. Come say hello. Come say hello. Let's say hello. Sheldon. Sheldon, what's up here? What's up here? No. What's up here? Oh, had enough? Okay, let's get down. I will help you down. There we go. Okay, bye. Bye, Sheldon. Bye, Penny. So, enough pet chatter for today. Thank you for coming. Bye for now.